Drawing is difficult because the world is complex. But as we study nature, we see principles at work that we can understand and make use of. One such principle describes how light interacts with form. You might think you understand this, but chances are that you're wrong in a subtle but remarkable way. Let's simplify this head into flat planes. Can you see that each plane has a particular brightness? Artists call this brightness the tonal value of a surface, or value for short. This value is lightest where the form is facing towards the light source, and the value darkens as the form turns away from the light source. This might sound familiar if you've studied shading, but there's a lot more you need to know. To become a master, you have to understand how the light and the plane interact. Every surface has a direction, and the light has a direction as well. There's an angle between the direction of the surface and the direction of the light. We call this the angle of incidence. If we rotate this plane so it faces straight up, the angle of incidence is 0 degrees. The light is hitting our plane with full force, so the brightness we get on the plane is 100%. Now, let's rotate the plane away from the light source. As the angle of incidence increases, the brightness decreases. Finally, at 90 degrees, the light no longer hits our plane and the surface falls into shadow. So, at 90 degrees of inclination, we have 0% brightness. Now, here's my big question to you. How much brightness do we have at 80 degrees of inclination? If we rotate this plane towards the light by 10 degrees, how much brightness do we gain? We go from 0% to what? Take a piece of paper now and write down your best guess. Go ahead and pause the video if you need a moment. You will only learn the main lesson of this video if you actually stop and think about this. Ready? Okay, here we go. At 80 degrees of rotation, we have 45% brightness. Yes, really. The first time I did this exercise, I estimated we would have 10% brightness. Maybe something between 10 and 15%. That's intuitive. But what actually happens in nature is this dramatic jump. Now let's go to the opposite extreme. We're back at 0 degrees rotation and we have 100% brightness. How much brightness do we end up with if we rotate the plane away from the light source by 10 degrees? Pause again and write down a number. Ready? At 10 degrees rotation, we go from 100% brightness down to 99%. How is that possible? Well, here's the entire scale. 100, 99, 97, 94, 89, 82, 73, 62, 45, and 0. This, my friends, is Lambert's emission law. It is named after Johann Heinrich Lambert, a Swiss polymath. Fun fact, I'm also Swiss, but I'm not great at math. This image shows a linear value scale with even steps going from 100 to 90, 80, 70, and so forth until 0. That's what we would expect. But what happens in nature is this: 100, 99, 97, 94, 89, 82, 73, 62, 45. And here is what this means for us. In shading, the tones change very slowly near the lightest lights. They begin to darken more dramatically as they approach the terminator.
Trust me.
The terminator is the edge between light and shadow. You can see how subtle the value change is in the lightest area on this planar sphere. In fact, if we place our two scales on top of the sphere, you can see how the linear scale gets way too dark, way too early. And check out this graph. The tone changes slowly as the form turns away from the light. but the closer we get to the shadow, the faster it darkens. This curve follows a cosine function. On the other hand, the linear scale progresses from light to shadow in a straight line. Don't worry if you don't know about cosines. You will still be able to apply this principle to your drawings. I didn't know back then, but if you do know this, you can save so much time. Also helps you to avoid two common shading mistakes. The first mistake is to make the light halftones too dark. This results in what we can call dirty lights. Ugh. You're ruining the light effect if you go too dark too soon. To maintain a convincing sense of light, you have to make the value change in the light values very subtle. These are clean lights, and these are dirty lights. Can you see the difference? Clean lights mean that you are respecting Lambertian fall-off. You're describing form convincingly and separating the light family from the shadow family. The second mistake is to not make the dark halftones dark enough. When you do this, you will see a light ring or a halo next to your Terminator. Watch out for this in your shading. It means that you haven't drawn the dramatic drop of value just before the Terminator. The way to fix it is to darken the values of the dark halftones until the light ring disappears. So here is before and after. See how much more round and convincing the drawing looks when the dark halftones are dark enough? This next mistake isn't related to Lambertian fall-off, but I want to throw it in because it's so common and so destructive. The third common shading mistake is to make reflected lights within the shadows too bright. When we draw from observation, we're often tempted to draw the reflected lights too strongly, too brightly. When we do this, the illusion of form is lost because the reflected light starts looking like halftones. So a good rule of thumb is to draw the reflected lights a little more subtly than what you see in front of you, or what you think you see in front of you. Here is before and after. Remember that rule that Stan has mentioned so many times? The lightest dark is darker than the darkest light. Make sense? Check out the links in the description for those lessons. Alright, let's put this into practice. One difference between a professional and an amateur is that the professional has a process. Here's the process. Establish the major proportional relationships. Then separate light and shadow by identifying the Terminator.
I'm a Terminator.
Tone in the shadow family with a flat value. Then shade the dark halftones first. When you get to the lighter halftones, remember to keep the value change very subtle. And finally, make sure that your reflected lights are not too strong. A head is, in essence, an egg shape. If you can't shade an egg well, you won't be able to shade a head well. So let's build a strong foundation and draw an egg. You can follow along. Begin with an oval. It doesn't have to be perfect, but keep your lines light. To begin shading, separate light from shadow. We do this by drawing the Terminator. Great. Now we can fill in the shadow. Now the most important addition we can make to shade this egg is to add tone where the value change is most dramatic. Where is that, you ask? Right next to the Terminator, in the dark halftones. Remember the common mistake? Not making the dark halftones dark enough? Let's make sure we don't do that, so watch out for the halo effect. To add the reflected light, we could lighten the shadow with an eraser, but that's usually a bad idea. It's easy to erase too much, and that's exactly the problem we're trying to avoid. So instead, it's much better to create the reflected light by darkening the rest of the shadow. Keep it subtle. Now we can move into the lighter halftones. Keep your lights clean. We must change the value as the form turns, and we must do so with more and more subtlety as we approach the lighter halftones. And here we go, a nice solid egg. Alright, if you've just been watching, now it's your turn. Draw an egg.